Good morning. We are going to be starting our training. And for this morning, what we have as a topic is how to improve efficiency of employees using data science. That is the topic of today. Our goal basically just to have an overview so that we have an understanding of what exactly we are here to do in the next 2 hours is first of all, we want to create a network. We want to create a network that looks like this. And this is a network of communication between employees. So using this network now, we want to get, the size of the network. Okay, size, strength, density, and all that. Those are tools for describing network. Then when we now get this size now, we now want to use this size to examine the performance of employees. Now, there are a lot of measures to check performance, but for this our example, we want to use publication output. Along the course of the training, I will explain some of these other measures that we're going to use to, evaluate the performance of employees. So using this size, we want to examine the performance of employee, and whatever we discover, we now want to use that to improve efficiency. So in a nutshell, that's just what we want to do in the next less than 2 hours. We have a lot of things that we might be mentioning along the way. And of course, I realize that some of these things might be new to us. Maybe we are just hearing for the first time. And that's why the video is going to be available immediately after the training so that we can use it to practice. And also, to be honest, I will slow down, but I might not be able to really slow down for you to be doing it as I'm doing it. So you might want to just pick up the video and then do your own after the training. And as a matter of fact, most of our webinars now will just package it as a video and upload it and then send it to you. So at your own convenience, you can be able to practice it. And then if you now have questions, okay, you can now post it on the group on Telegram. We have a Telegram group, so you might just send us your details. We'll add you to the group, and then you can be able to ask whatever questions that you want to ask. So that's basically why we're here. So for the outline for today's class, I'm going to be a little bit, go slow a bit so that we can be able to follow. So for the outline for today's course, we want to look at people analytics basically, and then we're going to be doing practical in Gephi, and we'll use an organization as an example. We want to use a college and a university as an example of the organization I want to analyze for. So these are the materials that you will need. We have already sent the link to the software installation video. The software is easily available online. It's the Gephi. And then the data, we also sent it earlier. So if you don't have it, just make a request and we'll send it to you. Then the lecture video, just like I said, will be uploaded. So introduction. It's always good for us to start from the very beginning and have a basics for whatever we want to do. So we are still on the business of business analytics, and we said that business analytics has 3 types. We have the descriptive, we have the predictive, and we have the prescriptive. So for the descriptive, like we said earlier, it helps us to describe what things look like now and what happened in the past. For the predictive, it helps us to know what happened in the past, and then we use it to predict the future. Then for the prescriptive, it links analysis to decision making. So what we want to talk about today, that's network analysis, finds expression in almost all the 3 aspects that we have here. So business analytics has major different types of applications. We have the financial analytics, that's when you want to apply it in finance. Then when you want to apply it in managing people, that's people analytics. Then customer analytics and operation analytics. That's when you want to manage logistics, supply chain, and so on and so forth. So let's talk about people analytics, which is why we're going to be zeroing down our discussion on. So people analytics, of course, is data driven and is an approach that helps us to manage people at work. Okay, so people are the most assets of an organization. Of course, that is a fact. And if you manage them well, you're able to increase on your return on investments. So, and thank God, thankfully, due to technology, we have a lot of data that is available on staff, which you can actually maximize to improve organizational, benefits or profits. So people analytics helps us to leverage on this. Now, how does it help us to leverage on this? For example, you want to know who you should hire, who should you promote, what career paths make sense within an organization. So those are the things that you want to investigate with people analytics. So it finds applications in organizations. They want to know that, like I said earlier, hiring issue, assessment issue, retention issue. Who should you retain and who should you let go? Then team composition, performance evaluation, and you can even check collaborations for better efficiency in the organization. So the last one is where we are going to be, is the example, sorry, that we're going to be using this morning. So collaboration. What is collaboration? Let's have a good understanding of collaboration. Then we now go to how we can capture it and analyze it. So collaboration basically is the act of working with other people to create something. And the beautiful thing is that this collaboration can be captured as a network. And we usually refer to that as organizational network. So why collaboration? Why is this collaboration important? Many organizations use this collaboration analysis, for example, Microsoft, the World Bank, and so on and so forth. And what do they use it to do? They use it to get people to work more efficiently together. They use it to help employees to be productive and more successful. So organizational network is one of the collaboration networks that we have. It's not the only one. We also have maybe co-authorship network. We have researchers working together, collaborating, and the list goes on and on like that. So if we are talking of an organizational network, for example, there can be a formal one. That is a formal structure of the organization. Let's assume that this is a university organization. You have your deans, you have the VC and all that. But this same organization can have an informal network, which is what I have on this side. So this informal network can be captured as a communication network, and that's what we can now analyze to be able to, provide the insights that we are talking about. So types of organizational network, we have communication, like I just mentioned. Then we have collaboration, we have friendship network, advice network, trust network, and so on and so forth in organizations. So it will amaze you that you could have so many of these networks in the organization that is not being captured. And if it's captured, it could be used to do a lot of things to improve that particular organization. So how can we describe this network? Like I always do for the training, we'll just look at the theories first, and then we'll now go to the practical, so that will lay a good foundation for the practical that we are doing. So how can we describe organizational collaboration? So this network that we are talking about, how can we describe it? The tools that we can use to describe it, they're network size, network strength, and so on and so forth. We have more, but we just selected these ones just for simplicity's sake. So let's look at the network size. What exactly is that? There are references. You might want to read more about them. So degree, and the reference is also listed at the back anyway. So degree, that's an example of a network size. So you have two types. You can have the in degree, you can have the out degree. So basically, for the in degree, You want to measure number of nodes connected from other nodes. So the number of nodes connected from other nodes. So you want to know who is interested in that particular individual. Then for the out degree, you want to know the number of nodes the particular node is connected to. So how is this individual, connected to other people? How many connections does he have to other people? Okay, so the network strength. So for the network strength, that signifies the strength of ties. We already know that there is a connection, but how is this connection? What's the weight of this connection? Is it weak? Is it strong? And then, you want to use that to do some things. So in Gephi, for example, which is the software that we're going to be using for the training, that one is captured by the average degree. Okay, so when you calculate that, we're going to go to Gephi and then we'll calculate it, and you know what I mean. But I just wanted to mention it here. So we also have network strength. Okay, so I think I explained that. That's the strength of the ties. Now we have network range. So network range basically has to do with how many different type of people we are connected to. If you look at this diagram, for example, you will see that for the first one that I have here is a low range network and is connected to the same kind of people. Maybe all the networks that is connected to is the people in the organization. Okay, maybe the person is on LinkedIn, for example, and all his connections are people in his particular organization. So that's like a low range network. And then the other one is a high range network, whereby you are connected to different types of people. So that means your influence is quite, more than the low range network. So that's what you use this network range to do. So the network range can tell you the ability of a particular individual to get information from variety of sources. Like this person now that has a high range network, you'll be able to get information from variety of sources. So depending on the purpose at hand, we might want to say that this person, network is better than this one, and so on and so forth. So let's look at network density. For network density, that one measures the degree of interaction between all members of a population and all other members. So if you look at this again, you will see that this guy has a high density and this guy has a low density. Why? Because we said it's an overall measure of interaction. So that means there is a lot of interaction going on with this high density network guy. But the interaction of this person is scattered, okay? And of course, it also, the network density, apart from what I just said, it helps us to give the overall interaction. And that overall interaction is, it's not individual based, okay? It's the whole network. You want to see how densely populated the network is, or what is the density of that particular network. So that's for network density. So it gives you, it's just a value that gives you how a network is dense or not dense. So the final one that we are looking at, though there are more of these tools for measuring or describing the network, but the final one that we are looking at is the network centrality. And we have a lot of network centralities actually. So that's why I just put the reference there so that you might just want to check out more. So network centrality. For network centrality, we have degree centrality. What does that one do? It helps us to find centrality based on the notion that important nodes have many connections. What are we saying there? We're just saying that we believe that you have influence. Centrality is used to measure influence. We believe that you have influence if you have many connections. Then for the betweenness centrality, we believe that you have influence if you are able to connect, a lot of important nodes. So we said has to do with finding centrality based on the assumption that nodes that connect other nodes are important nodes. Okay, so for the closeness centrality, formally we said they all have their formulas. That's why I put the reference there. So for the closeness centrality, we said it has to do with finding centrality based on the notion that nodes that are important are going to be a short distance away from other nodes. So if you are important, then you are a short distance away from other people. That's for the closeness. Then for the eigenvector centrality, is used to capture the notion that the more central the neighbors of a node, the more central the node itself. So we are saying that the central node is important. That's the eigenvector centrality. So those are the metrics that we are going to talk about. We have quite a number of them, which is much more than I just said. Okay, so now that we have seen how we can describe network, let's now look at how we can develop a typical network, organizational network. There are different types of network. Maybe I should just say that briefly. We have the maybe transport network, we have a biological network, we have different types of network. But what we are just looking at here is collaboration network, and particularly organizational collaboration network. So how can we develop, a network? Let's look at a problem scenario to make it easier for us to describe a network. So assuming we have an organization that is looking at improving staff efficiency, for example, and that organization is able to capture, communication data for their staff. And it's not only through communication, there might be other kind of network that they might want to create. So, and that will determine the kind of data that they're going to collect. So, and they want to use this, maybe because in order to do that, they now want to build a communication network of their staff and use that now to investigate staff performance. Okay, that is possible, and that is what we want to look at today. The first place to start is the data. Data collection can be in several, you might even want to collect it, you might not even collect it. It might be existing, it might be archived, okay? It might be on social media. It might be on maybe platforms like Scopus, if it's quartership network. It might be on different social media, like I said. It might be email data, how they are sending emails to each other. That's a connection, and you can capture it as a network. So phone calls, that's another way to capture communication network. So there are several ways to capture communication network. And then through survey, field work, and so on and so forth. So, but for the one we want to look at today, we are looking at basically the one that has to do with survey. Okay, so how do we collect this survey data? How do we collect this network survey data? First of all, the first thing you have to do is that you want to identify the sample. So when you identify the sample, what you're doing there basically is that you want to say, okay, what's the boundary? Maybe the organization is a whole university, but you don't want to use the whole of the university. You just want to use maybe a department there. Excuse me, please. So you just want to use a department there. So that's a boundary. Then even in that department, you want to discover, or you want to decide, what is the sample size? How many people am I going to use in this department? Please excuse me again. So you want to decide how many people am I going to use in this department. After that, The next thing is that you now want to create a survey. And of course, like any survey, your survey should have an opening statement. Let's look at what that looks like. You want to tell them that what this questionnaire is about, and so on and so forth. Then now have some questions that helps you to get information about those people that is actually going to be filling the questionnaire. So those are the age and so on and so forth. And for example, in this our example, we want to look at, we want to measure performance. So and we have chosen to measure performance using publication. So that informs the reason why there's a question here that says, how many publications do you have? And well, when you are doing things like this, you might not even want to ask the staff how many publications, because they might not want to be truthful. So there might be other ways of getting this performance or number of publications that will be more authentic and be more correct. So, but this is just for the purpose of demonstration. So now the next thing you want to talk about is the network questions. So for the network questions, we have an example here that says, do you communicate with these people? So in order to come up with this, first of all, like I said, you need to define your sample size. So is that sample size now the number of people? So if you say you are using 20 or 30 people, all those people have to be listed right where my mouse is flicking here. So you need to list all of them. And then the particular person that you are giving the questionnaire to, you are now asking him that, do you communicate with these people? So it's a yes or no thing, depending on how you want to capture it. So for example, this particular person now might not be, because he's the one that you are giving the questionnaire, is not is going to have, no answer here. But if you are now asking him that, does he communicate with CSL? If he says yes, CSS, STU, if he says yes, and then this other person, if he says no. So you just give it to him, whoever you're administering it to, and let them fill that. So that will help you to get the network data. Okay, so that's what we're going to use to create the edge list for the network just in a minute. So those are the network questions that you want to put there. And the next thing, maybe you have any additional questions just to know the respondents very well. And of course, it should not be too long so that they will be able to answer you appropriately. Then you administer the questionnaire, of course, and you monitor it to make sure that things are done in order. Then finally, now you have your questionnaire, you need to enter the data and then visualize it and create the network. But just a quick one on entering the data. When you want to enter the data in your Excel sheet, though for the example we are using today, I've already sent the data that we're going to be using, so we have already skipped this stage of gathering the data, but it's important why we put this here for someone that wants to, experiment in his own organization or something. So entering the data. So for entering the data, the first thing you need two types of yes, you don't have the data. Somebody's saying that he doesn't have the data. I'll send it to you after the class. Yes. So for the first thing you need, okay, you need two Excel sheets, or you need two types of form of data. The first one is what we call the node list. So for the node list now, that is what helps you to capture the first part that we talked about, which is the questions that you ask, the background questions and all that. And also there you will have your data on performance. Okay, so it's important whether you want to get it from the respondents or you want to get it from the organization itself. So now, when you have this node list, you need an ID column. Okay, I'll say something about this later. Then this label can be anything actually. Then the next thing is from this column C, D, E, F, those are the things that you have captured from the questions that we have here. So after that, you now want to create this, you want to enter this from the questionnaire that you administered to people. So Entering the data in Excel. When you are entering the data in Excel, that's the second part now. That's the edge list data in Excel. You have something like this. So you need a source and a target. And that will be informed by this second part of the questionnaire, which you asked, which I was explaining the other time. So the source is who you have given the questionnaire, and it's the one that you're asking whether he communicates with another person. So assuming this HOD person, which has no response here because it's the one that is filling the questionnaire, is the source. Then the target will now be this CSL person. So this CSL person, because he said, he communicates with this particular CSL person, that means that this number 2 here can be created. So that's how we got this data in this Excel sheet, this first edge list. So now, for this second person, you also check he communicates with this person. So that's what informs this one. And then you keep going on and on like that till you have created your edge list. So having settled the data issue, the next thing that I want to do is, how can we evaluate organizational collaboration network? And when we talk about evaluating organizational collaboration network, what we are simply saying is that we want to get insights. We want to get insights to this network. So now, getting these insights, helps us to recommend steps or actions that we can do. So there are different types of insights that we might want to get. Okay, we might want to find out whether is a network good or bad. We might want to find out, are people doing what they're supposed to do collaboration-wise? So all these questions will be determined by the particular application scenario. Then, in order to answer these questions now, you now want to, first of all, answer some of these questions. There are other questions, but these are the most important ones. How do collaboration patterns vary? Then, how do collaboration patterns matter for important outcome? So this can be done, particularly the second question, can be done for individuals, group, and organizations. But for this example, or this practical that we're doing, we want to look at the individual perspective. So let's go to the first question. How do collaboration patterns vary? Okay, so using simple descriptive analytics, we can pick network size, for example. And like I said, network size is captured in degrees, whether in degree or out degree. So based on this network size, you might want to compare across different individuals. So these degrees that we are looking at here, for example, you might want to compare it according to different individuals so that you'll be able, and also even compare it over time so that you are able to see, what is happening with this particular individual's degree, over time, and so on and so forth. And I will tell you the implication of that later. And these results, okay, can be used for managing employees in different areas. And it's not even restricted to just this 4. Performance assessment, roles and responsibility, so pay and promotions. For example, if you might want to use it to determine the pay. If somebody like this BIOSL now, it doesn't have any degree, it's not communicating with anybody, even though he has what he's doing in the organization, you might not want to remunerate him the same way as somebody that has a 20 degree, because that other person with a 20 degree will be doing so much together with his own work too, as per communication. So those are the things that determine that those are the ways that you can use it to determine remuneration and so on and so forth. So 2, how do collaboration pattern matter for important outcome? Now, let me just say something here. There are different types of outcome. Outcome might be in form of performance, where you want to check, okay, how many sales is this person bringing in? You might want to ask the person to even to rate himself, or the manager should rate the person. And for example, in academic environment, you might want to measure performance based on number of publications and so on and so forth. That's a kind of outcome. Performance is not the only outcome that you might want to measure. You might also want to measure satisfaction, commitment, turnover, and so on and so forth. So those are the kinds of performance, those are the kind of outcomes that you might want to measure. All right. So now, with that now, having understanding of those two questions that we can use to evaluate performance, let's now, pick just an example from the tools that we described earlier and from the outcomes that we mentioned just recently. So let's come back to our application scenario. In this particular organization that we are talking about, we can decide to do a correlation analysis between size, which is one of the tools of describing a network, and performance, which is a particular outcome. So we want to find whether the two of them, whether they are correlated. And a simple way to do that is to use your Pearson's correlation efficient. So the insight that you might want to get out of this, for example, is whether you want to investigate, is it true that as the degree increases, publication increases? So if you have that, if you have the answer to that now, that can now determine what will be your next step, what will be your intervention step, or how would you improve such a network, and so on and so forth. And remember, our goal is to improve efficiency. So if efficiency has to do with having more publication, and we have seen that as degree is increasing, publication is increasing, then that means that we have to look for how to be increasing the degrees of these individuals so that they will keep increasing their publication. So that is just a simple example to illustrate what we're talking about. So now, let's now see, having gotten this insight, how can we use this insight to improve efficiency? There are so many ways to do that. First of all, you even need to ask whether collaboration is even needed at all, because sometimes it might not even be needed. So now, based on what you discover, if, for example, we discover that the number of publications is not correlated to the degree of the individual, that means that there's no reason for you to start tampering with your collaboration and so on and so forth, because it doesn't have any effect. So, but if it does have effect, where is this collaboration needed? And how would you strategically build this collaboration? Okay, so in order to do that, there are so many things. For example, if you have decided that the collaboration is needed, there are so many ways to improve upon this collaboration. You might want to provide motivation to build ties, provide opportunities to build ties. So you just create an environment as an organization where people keep connecting, because the more they connect, you have seen that it leads to increase in productivity. Okay, so now we'll go to the practical side. And in order to do that, I would have to go to Gephi. So I'm going to share my screen, the Gephi screen. Okay, so right now we're in Gephi. As soon as you install the Gephi software, which is what we sent to, that's the link, we send the link to the video of how to install this to your email. If you don't have it, you can request for it. So as soon as you install Gephi, this is what you are going to be seeing, and you load the Gephi, maybe from the shortcut on your desktop. This is what you will see. So having seen this, you can click on New Project. So when you click on New Project, it will show you, it will show you this environment, and From this environment, you have already captured your network data earlier, and we send the files to you just for practical purpose. So you load in the data file. Under file, you click on open, and you click on the network data. So let's bring in the edge list first. So you have something like this. So from here, I'm still going to explain the difference, the interface from this for this Gephi software later. But from here, what you have is that you have the data being imported into the Gephi software. You want to click on next, but you just want to be sure that is the correct kind of data that it has brought in, which is your edge table. So since everything is in order here, I don't need to adjust anything. I just click on next and finish. So we have an interface here. So this interface is just telling us, it's giving us the idea of the data that we have imported. So we have about 26 nodes, 255 edges. So the next thing that you want to do now is to is to say okay, and just be sure. Maybe I should just say something here too. We have two different types of network. We have the directed and the non-directed. So for this, our example, directed network, actually, what it means is that if you are communicating with somebody, there's a direction to the communication. For example, in Twitter, there's a directed network there. But if it's maybe authorship collaboration, for example, that might not be directed. Everybody's communicating back and front. So like two types of network that we have. For this, so the mixed is just when you have the two together. So for this, I'm going to click OK because we're having different types of network. In this, our example, that's when we have communication between people in an organization, maybe in a department, in a university, so it can be any way. So that I'm just going to pick the mixed. So for that, after that, I'm going to click OK. So now we have our data, it's been loaded. That's the edge list. So what it brings us to actually is the data laboratory. That's where we have loaded the data. So it has taken us automatically to the data laboratory. So in this data laboratory, we have nodes, and then we have, so it's actually, by default, it comes to the node. So you have an idea of all those people that participated in the network experiments, okay, that you're doing. Then you have the edges. Okay, so you can see that the edge, the source and the target that you loaded is reflected here. And then there's some other information. So we are going to go back to the overview. So we're going to click on the overview tab. So by clicking on the overview tab, you will see that because you imported an edge list, the network that is created from that edge list automatically appears there. So now your network is imported, you are ready to go. You are ready to start discovering some things and doing some things. So let's, like I said, I'm going to introduce us to the different interfaces, but let's just do one or two things before that. So first thing that I want to do, let's look at the layouts. Okay, let's pick a different layout. Let's select the layout that we want and run an expansion and just see what happens to this network data. So I'm going to come here and I'm going to pick a particular I'm going to pick a particular layout. That's Frenchman Regold. So that is the layout that I've selected. So when I pick it, I can run. Click on run, and then you see something like this. After that, I want to expand it a bit. So if you want to, if it's not necessary, okay, some of these things are just, they are cosmetics. It depends on how you want your network to look like. That's what will determine what you are going to be doing here. So, but I want to see some other, but before you can change, you know, some other, if I can work on this layout, you have to click on stop. So now let me expand it. If I want to, I can click on expansion and click on run. So you can see that it's bigger. So you can keep expanding it to the size that you want. Now let's talk about these Gephi software interfaces. Right here is what we have, what we call appearance. Okay, so this is where you do the cosmetics. This is where you do how you want, how beautiful, colorful, and all that, sizes and all that you want your network to be. This is where you do that. So, and after that, you have the you have this layout section, and we have already interacted with it, so you have an idea of what you can use it to do. Okay, select different types of layout for your network and so on and so forth. Now we go to the statistics window. So for the statistics window, you have first of all, you have the tab for statistics. Okay, so which is where my mouse is right now. So these are all the statistics that you can run on this particular network. So as a matter of fact, sometimes when we are doing research, we just want to run everything, and then the one we need, we pick it, the one we don't need, we pick it. But if you know which one will actually give you what you need, you can decide to click on it. So when we get to the practice, that's when we are doing our example that we selected, we'll talk about that. So now, the next thing now is the next tab that I also want to introduce to us is the filter tab. So the filter tab helps us to also work on this network. Maybe, for example, you have discovered, because some of the things that you can get in the network are the clusters in that network. So maybe, for example, you have discovered that there is a big, or there's a community in that network. There's the largest community in that network. You are interested in finding out who is actually rocking this largest community. Okay, you can do a filter and get out that particular largest community. You're going to be doing that too in the course of the lecture. So the next pane that we might be interested in is the data laboratory. So I'm just going to go right ahead and click on the data laboratory. So for the data laboratory, you see that it gives us an idea, like I was saying earlier when we imported the data, of whatever you have calculated. Right now we have not calculated anything, but when we calculate, we are going to come back to this place. So it gives us an idea of the result of what you calculated, the data that you brought in, and so on and so forth. So those are the important. There are other panes like the preview and all that, but I'm not going to go through everything. You can explore that for yourself. But those are the important windows and panes that we're going to be using for the lecture today. So I'm going to go back to the overview. And I want us to start customizing the network now. Before we start running our analysis and all that, let's do a little bit of customization for the network. So as a form of customization or cosmetics, I might want to customize based on size, maybe degree, the degree size. So what I'm going to do there is that I'm going to come to this. This is for color, this is for size. So I'm going to click on size while I still have my node highlighted here. So please, you can follow the direction of my mouse. That's what I'm using to do the explanation. So I can click on size, and while I still have my node here, I can also click on ranking and then choose an attribute. I can click on ranking and choose an attribute. So the attribute that I'm choosing right now is the degree. Okay, so now we have the degree. So for this degree now, I want this network to be customized based on the degree. I want the network to be customized based on degree. So in order to do that, what I did was I came to size, I'm repeating myself, and I make sure the nodes is highlighted, and then ranking, and then I have degree here. So it's going to rank all those nodes based on their size. So if a particular node has a high degree, it's going to be reflected when I click on apply now. So I'll click on apply. So you can see what has happened. So this means that these are the nodes. For example, this node that my mouse is on, it has a high degree, and so on and so forth. So those are, and it's not just restricted to what I just did now. You can try it, you can experiment, and just like I said, it's cosmetics, depending on what you want to emphasize using this network. That's what is going to determine how we are going to be doing this cosmetics. So the next thing that I want to look at, of course, is customizing the network using another kind of layout, for example. So I want to change it from these layouts that we are using. Let's try another layout. If we have another one there, let me see, we have Yifan Hu. Okay, so let's just pick that, and let's run that, and let's see what it looks like. Okay, so we can see that it has squeezed everything, so we can't actually see the beauty of the network. So in order to solve that problem, we can now run an expansion on this particular layout that we have selected. So if I click on expansion, I can click it and let it keep expanding so that I can see what is going on there. So we can see what is happening. Okay, so I'm going to stop at that. So we ran the expansion. So the network is looking a little bit dull. We can decide to color it and then make it look interesting, depending on, like I said, there are so many ways to manipulate this, which you can explore on your own, but I'm just going to pick simple ones, and then we are able to relate to that. So now for the color, let's try clicking on the color here. This is for color. So when we click on this, we are still talking about nodes. So our tab of nodes is still on. And then we now pick a particular color. Okay, so if you click on this, you'll be able to now select whatever color you want. So I'm just going to click on that while holding it down and look for a nice color that I want to use. Okay, so I can use this. So I've already selected that color, and I can click on apply. So if I click on apply, you can see that the color is different. The sizes of the nodes are also different. So you can just keep working on this to get whatever you want. So, and you can see that the color is lighter when it comes to small ones, and it's darker when we come to another one. I can actually pick another color so that we can be able to see that very well. Okay, let's do this. Okay, apply. Okay, so that's that. Then let's now talk about the node labels. Now that we have seen different sizes, we are interested in, maybe we are interested in some big size nodes, but we don't know who they are. We might want to turn the label on so that we can be able to know exactly who is this person. So in order to do that, we come to this pane and we come and adjust that. But before we do that, so that we can have all the data that we need, it's very important for us to load the second Excel sheet that I gave, that we sent. And that is the Excel sheet that contains the node labels. Because we cannot know the name of these people. We have not told Gephi their names. So we need to bring in their names now. So how do we do that? Okay, so we go straight to our data laboratory. And we click on imports. Import spreadsheets. Okay, so you should have prepared another an Excel file that contains the node list. I explained what node list means earlier. So you should have prepared that earlier. So, but for this training, we had already prepared it. So for the node label data, you click on it. We brought in the edge list earlier. So for the node list label, you click on it and then you click on open. But I should just say something here. If you want Gephi to recognize the data that you are bringing that describes those edges that you loaded earlier, you need this ID column, okay? This ID column must tally with the ID of your nodes in Gephi. They have to be the same, so or else there will be an issue. For example, if I click on nodes now in Gephi, I'll bring in the Excel sheet again. Let me just show you something. This is the node, okay? If I say import and I say node label and I say okay, for example, this ID that I'm looking at here in the data that I'm bringing in must be the same as the ID that is in Gephi, which you imported earlier. So what we are simply saying is that when you're preparing both your edge list and your node list, you should make sure that there's an ID column there. The ID there should be an ID column, ID, and it should be the same thing when you are preparing the data. Then you will not have any issue. Okay, so having said that, we have loaded the node list table now, and we click on next, and then we click on finish. So this is just giving us a statistics or an overview of the edge list that we just brought in. So with that now, we are free to click on OK. Another thing that I should also say here is that before you click on OK, pay attention to this. Append to existing workspace. So when you pay an attention to this, you are able to, what that is doing for you is that it brings in the node label data into the same workspace of the edge list data, or else they won't see each other and it might not work. So I'm just going to click on that and I'm going to click on OK. So you have imported your edge list now. So after that, the next thing that you want to do, okay, we have our we have our node labels right here, and then it will help us to, label those nodes that we talked about. So let's now go back to our overview. Okay, so back to the overview now. That data that we brought in will help us to be able to label this particular network. So back to the overview now, I can now turn on, back to the overview now, I can now turn on the labels that I brought in just now. So in order to do that, I'm just simply going to come here. You can see the labels have appeared now. So that means that from this now, I can actually see who is this guy, okay, that has a lot of degrees and probably has a lot of influence and connections and all that. So that's for the label. So I can also color by the age attributes. So you can do a lot of things, like this is just cosmetics. So you can decide to picture it however you want it to be. So let's color by age attributes. So in order to do that, remember we are still on the nodes. We are still dealing with nodes. So if I click on nodes and I click on color, okay, color is there. Then I might want to come and click on ranking. And remember the data we brought in just now, earlier we didn't have age because it was not brought in into Gephi, but now we have age based on the node label list that we brought in now. So we have age. So we can decide to color by age. And so we can see what has happened here. We can see that this particular person has, we did the node by degree. So the size, so it has a lot of degree, judging from the size. And also judging from the color, is quite advanced in age. So that's the beauty of network. Those are the things that you can actually discover from this network. So let's proceed. We can now we can also try the label size. So this label too, we want to also let the size of the label be based on whatever you want to make it to be like. So for example, I can do the label size based on the degree. So how do I do that? I'm going to come to label size here and click that. And we are still on the nodes, so this is clicked. And then I'm on ranking because I'm trying to rank them. And then I click on degree. Okay, if I apply that, let's see what will happen. Okay, so we can see that the label size has also increased based on the degree. So depending on what you want to emphasize when you are creating this network, that's what will determine what you are going to be using, what we're going to be picking in this appearance. Like I said, appearance is just cosmetics and it helps you to emphasize something to your clients and so on and so forth. So that's that for the appearance. So we have done one or two things there. So let's just continue. Now let's move to the analysis. Let's come to the analysis, because remember our goal is that we're trying to look at efficiency, and then we want to do that using a network tool called size, which I explained earlier, and we are looking at it with respect to performance. And we said for this example, we're evaluating our performance using number of publications, for example. So let's now go to the analysis. So enough of cosmetics, let's do some analysis. So to do the analysis, we click on statistics. So for the statistics, just like I explained earlier, there's so many things that you might want to run. So what Gephi is telling us is that you will have all these statistics. If we click on all of them, all these statistics will be computed for this network. So, but I'm not going to do everything for time's sake. I'm just going to select some. But how would you know which one to select? It depends on what you're looking for. For example, anyone I'm going to select now must have degree, must help me to calculate degree, because that is what I want to use in this my experiment to measure performance. So I click on I can run this. Okay. So whenever you run any of this, so I'm just going to speak to them one by one and then we can continue. So if you run degree, for example, you see an interface that comes out. So for this interface, it's telling you the in degree, the out degree. I think I explained this earlier. So this is a report of that. So and it's giving you the counts and so many other things. So I'm going to run different ones because this is still on degree, in degree and out degree. And one very good thing about this output is that it will tell you the algorithm. If you take your time to look at that output, it will tell you the algorithm that is used to calculate that particular degree if you want to find out more about it. So for the next thing I'm going to run the network diameter. Okay, the network diameter. So because it's not directed, I just want to click on that. So we have that. So if I run this network diameter, for example, it has given me a lot of things based on centrality. Remember we talked about centrality earlier, betweenness, closeness, and so many other ones. And the algorithm that is using is stated here. Okay, so let's run some other ones. Let's run density. We will also need density. Okay, so let's run density. Okay, so we have that. Then let's run modularity. Modularity, that one helps us to get the clusters in the network. Okay, so if you look at the modularity results, for example, it's just telling us that we have about 5 or 1, 2, 3, 4, 5, 6, 7. So it has given us about 5, sorry. 1, 2, 3, 4, 5. Okay, 6 clusters. And the number of members of each cluster is what we can see here. For example, we have this one and this one having about 9 members. That's cluster 1 and cluster 2 having about 9 members. So that's for the clusters. We're going to see the output of all these things that is giving us the results just in a minute. So another thing that we might want to run here is the connected components. Like I said, you can run everything if you are not sure of which one to run. So, and then at the end of the day, you just pick the results of the ones that you want, that you need. Okay, so we ran connected components. Then let's run another one, average clustering coefficient. So we might find out what exactly these things are. You might want to find out, later. So I think we pretty much have what we need. So then average part is calculated for. So you might just run everything if you are not sure, and then when we get to the statistics, you pick the one that you actually need. So basically, having run all that, let's go and see the result of all the things that we ran. And that result will be found clicking our data repository or data laboratory. Okay. All right, so we can see the data laboratory. We can see that we have quite a lot of things compared to what we had earlier. In addition to those things that we got from our questionnaires, that's in the node label list. So we can see that we have age, publication, we have in degree, out degree, so many centrality, betweenness, and we have all those values for each of these people that participated in that experiment. So we have a broad, statistics that is calculated for us just by the clicking of the mouse. And so it now depends on our goal and what you want to use these statistics to do. For example, in these experiments now, we want to use want to check size. Want to use size to investigate performance. And we said our performance is the publication, which we have here, right where my mouse is. And the size is the degree. So this is where Gephi has been able to help us up to. So if we now want to do that correlation that we talked about, the next thing for us now is to export this data. So probably to Excel or something, and then let's go and calculate that correlation so that we can get the insight that we want to use to, inform the efficiency and so on and so forth. So I'm just going to go, but before I go to that, let's just do some filtering. Let's see some things about this network. So I'm going to go back to my overview. And I want to filter. So let's do something in the filter tab. I want to filter, and what I want to filter is I want to get the largest community in this network. The community that we said earlier that has maybe like 9 people and so on. And so we want to see that. So how do we do that? So we'll use the filters tab for that. So if I click on the filters tab, I have attributes and then equal. So what do I want to use for this, my filtration? Like I said, the goal is to check the largest community, and the modularity helps us to calculate community. So I'm just going to drag the modularity like this and drop it here. So with that now, I'm now able um, to select which is the largest community. And how will I know what I'm going to type here? That will be determined by, when I calculated the statistics, the modularity that has the highest, that's the number that I'm going to have to put here. So in order to do that, let's just go and check the statistics again. I'm going to try and run the modularity again so that I can get, okay, all right. So now we have that particular cluster that is named 0 has 11 members. So that is the highest community. That's the community that has the highest people closely networked together. So that's 0. So let me use that to filter now. Okay, I'm going to close this. I'm going to go back to my filters and I'm going to type 0. Okay, 0 is there by default. So I can say select. So you can see what has happened. So this is the largest community in the network that we developed. Okay, so that has filtered that. And okay, so this makes it more clear. So we can see the largest community. Now, if you don't want to see this again, you can just click on stop and then your network comes back. So that's just visualizing the largest community. Now let's visualize based on centrality. Since we have calculated some more things, we can use those things that we calculated to also visualize this network, in addition to the age that we used earlier. All right, so now in order to do that, I'm going to click on nodes as usual, because it's the nodes that it's calculated all those things for. And I'm going to click on size, and I'm going to click on ranking. Then what do I want to rank by? Let's see some of those new things that was just newly calculated. So let's look at maybe betweenness. Betweenness centrality was just calculated. So I want to apply that and click on apply. Okay, so we can see what has happened. So I can try other things. I can try maybe closeness centrality that I can apply. So we can see that we can see what is happening. So depending on what you want to emphasize or what you want to pass across, that's what will determine how you just do the appearance here. So I think we've had enough of cosmetics. You can try some other things on your own. So let's go back to the correlation that we set out to do, that we now want to get insights that will help us to improve performance. So like I said, on your data laboratory, you want to click on export the data. So all this data, all the things that we calculated here, you can export it to an Excel. So I'm clicking on export. So it's going to ask me that I should give it a name. There's a name there by default, but I'm going to give it a name. So let's call it organization. Okay, so I'm going to click on save, and I want you to put it on the desktop. Right. So now we have exported it to the desktop. That's how much Gephi is planning to help us with. So we are now going to go and do the conclusion of the analysis in Excel. So I'm going to minimize my Gephi screen and go to Excel. So I'm going to be sharing my Excel screen. Please, if you cannot see the screen, let me know, please. Please just type if you can see the Excel, just say yes. That means we cannot see the Excel. I want to try and look for the Excel. Okay. Please, if you can see the Excel now, just say yes. Okay. So for the Excel, this is the Excel screen. And this is the data that we exported. I just opened it. We said you should put it on the desktop, so I opened it. So this is that exported data in Excel. Now, what we're actually interested in is the publication column and the degree column. So I'm just going to, you probably want to save another version before you start deleting anyway. So I'm just going to remove, I'll leave the ID, and I'm going to remove every other thing apart from the publication and the degree. So all these other things, they're very useful. I'm just deleting them because we don't need it for this particular experiment. But all this centrality and all that, we can use it to investigate so many things in the network or in our experiments that we are conducting. So I'm just going to stay with these two. So, and in Excel, we can easily calculate our correlation, metrics, so that we want to see whether there is a correlation between publication, which is performance, and degree, which is size. So I'm going to go to the data analysis. I'm going to go to data, yes, data analysis. And I'm going to bring in Excel. So I'm in Excel right now, and I'm going to bring out correlation. So it's correlation that I want to do. So I'm going to select the columns that I want to correlate. You can see that. Then I'm going to ask it to use the first row as a label. And I want the output range to be somewhere here. Okay, so let me do that again. Correlation. So I'm interested in correlating this. Okay. Then it should show labels, and let's have the output range here. Okay, so let the output be there. And I'm going to click on OK. So it has given us the correlation. So that means that the correlation between degree and publication is 0.3. In order for us to actually understand what this correlation means, I'm going to go back to my PowerPoint and show us the Pearson correlation formula, or the coefficient, and what it actually means, so that we'll be able to understand what this 0.3 means. So that means that the correlation between degree, which is the network size of that individual, and the publication, which is performance, is 0.3. I'm trying to bring up my PowerPoint. I'm trying to load my PowerPoint. Okay. So I'm trying to share the screen back. Okay. So back to the PowerPoint. So now this is what we want to calculate in Excel. So this is the correlation results that we got. For us to be able to understand these correlation results, I just want to show us this Pearson correlation because that's what Excel used. So usually this is the formula that was used to calculate it, but we now have these interpretations. For example, the result we got was 0.3 something, which falls where my mouse is right now, meaning that's 0.4 to 0.2. And what that means that the strength of the variables is poorly related. Poorly related. So there's a poor relationship between publication and degree. Now, how can we conclude with that? We have 0.3, meaning that the strength of the variable is poorly related. That means there's no particular correlation between the publication and the size, which is performance and the size of the network for individuals in that particular experiment that we investigated. So the insight that we can get in that, for example, is that we might not need to start trying to improve organizational, collaboration, because it doesn't particularly lead to improved performance. But if, for example, the strength, what we got was something like 0.9, okay? So it falls in this range. This means that the strength of variable is perfectly correlated in a positive way. So that means that the correlation between the size we investigated and the performance is positive, there's a high, correlation there. Oh, that's a very wonderful insight. So what we can do is that if we want publication or performance to continue to increase, we can now focus on the network. How will individuals be able to have a lot of degree connections? Because we have seen that connection leads to increased productivity. So, and that brings us to the last one that we talked about, that how can we improve, collaboration? So if we have seen that in the organization, we want more publications, and we have seen that network size, the more the network size, the increase in the publication, for example, then we can now say, okay, how can we improve this collaboration? How can we help individuals to build more collaboration? Okay, so that's, maybe you want to provide motivations to build collaborations because you have seen that they need more collaboration, or you want to provide opportunity to build more ties, which will now help us to have a lot of productivity going on there. So that's how we conclude the journey of trying to improve efficiency of employees and so on and so forth. Just like I mentioned earlier, this is just like an example. So depending on the kind of thing that the organization that you want to investigate uses to measure performance, that is what you are now going to be using against those metrics. And I just picked size. There are other things. We can use influence. Those are centralities to check performance. We can use network range, network density, and so many other tools to investigate performance. So these are valuable things that we can use data science or data analytics to do, analysis that we can use to do in an organization, and of course, increase productivity or efficiency as the case may be. So these are some of the references, and I think that is where we are going to stop. Just like I said, we want to change the strategy a bit so that we'll send most of the trainings, when we do it like that, we'll send it to you. And if you have any question, you can just post it on our Telegram group, okay, instead of meeting every weekend like we used to do. But if we still meet weekend, we'll let you know. Thank you very much for coming, and we will see another time. Thank you.